We left off on our last section with a wrap-up of some of the concepts we introduced. The Cartesian coordinate system you were familiar with. We introduced preparatory functions, the concept, the letter G followed by some code, be it a 0, 1, 0, 0, number 20, number 90, that somehow prepares the control to behave a certain way. G90 in our example, and on our control tells it that all coordinates that we enter are absolute from a 0 point. The G20 says that those numbers, those values, are inch units. And then the G00, if you remember, was a rapid move. And then G01 was a linear move, an interpolated move at a feed rate. And linear implies that it's parallel to axes, or it can run across and do a two-axis move. So it can cut angles or straight lines up and down, right and left, and it can cut angles at G01. And that all the cutter is doing is following the points around the path in the order that you type them. Now, this is page number 26 in your manual. And what I'd like you to do is look at it, because now I want to introduce you to the concept of machining circular segments. We've worked on several straight line segment examples, but now we want to get into cutting the circular segments. So, here I have the sketch. Here's our origin axis right here. And here we have a line that kind of takes a straight shot, makes a radius, takes another straight shot, makes another radius, and continues to an endpoint. We start and approach this the same way we have been, understanding and writing down the x and y values of our endpoints. So the x and y value of our start point becomes x minus 19 and y 5. Point number 2 is at x minus 8, and now point number 2 and 3 is the beginning and end of the arc. But we still need these points in terms of x and y, so point number 2 is x minus 8, and it's still at y plus 5. Now, what is the location of point number 3? This happens to be a 90-degree arc. How do I know it's a 90-degree arc? Because if this is the center of our arc, it's 2 units this way and 2 units that way. So this now means that it's a 2-inch arc radius, right? Half of a diameter is a radius. So we still need the endpoint number 3, and that would be at x minus 6, y plus 3. And now we'll get point number 4, and that stays at x minus 6, but becomes y minus 4. Point number 5 is at x minus 4, y minus 6. And our endpoint number 6 is at x positive 5, y minus 6. Now, based on what you know so far, how is this line going to look like if we input these coordinates? So if we go and we make this G01, x minus 19, and so on. You're familiar with the axes labels by now. So by me saying G01, x minus 19, y 5, and then of course we want to tell it a feed rate of 5 inches a minute. What then is this line going to look like as the controller executes each of these blocks? Well, it's going to go to x minus 19. It's going to go there, y 5. Then point number 2. This is point 1, point 2, 3, 5, and 6. It's going to go to here, right? It's going to go from here, it's going to make a straight line move to here at x by 8. But now it's going to hit this, and because we're in GO1, it's going to make a straight line move to there. And then it's going to go down to point number 4. And then it's going to cross over to point number 5, and then it's going to end up at point number 6. That's what it would look like, but that's not what we want, is it? That is not what we want. What we want is a radius of 2 units that goes from point 2 to point 3, and a 2-unit radius that goes from point 4 to point 5. That's what we want. To cut a radius, all you need to know are 2 things. You know that it will begin at a known point that we get to with a linear move. All we need to know is where we're going to end up, what the x and y values are, which we found by simply recording them. But now what we need to learn, or need to know, is where does the center exist in relation to our start point. And these distances, and we'll talk about these in a minute, they're identified by the addresses of I and J. But before we go into that discussion, we also need to consider, is this going to be a clockwise cut, or is this a counterclockwise? Because we could just as easily make a radius like this, right? But in this case, we want it to be a clockwise motion. And this one, based on its center location, we want it to be counterclockwise. Because this one could just as easily come this way too. So, we need to know the direction, we need to know where we're going to end up, and we need to know where the center is in relation to the start point of the arc. Now let me show you how we figure that. We're going to go down, we go from point 1 to point 2 at a G01. That you understand. We're going to go from here to there in a straight line move. So this line here, line number 2, leaves us sitting right here, right? Point number 1 puts us there. The control then executes the GO1 to these coordinates, so it puts us here. Now, where is the center point? The center point, according to that drawing, and my drawing is not as good as it is up on the board, but it's showing that our center point is 2 units, or 2 inches. It's a 2-inch radius arc that we want to cut. So here is our center point. Here's where our center point would be of this arc. We're sitting here right now. So where is this center point in relation to where we are right now? It is on the same x-axis as where we're sitting. So what we think of in terms of x and y for the circle center are 2 new words, I and j. So the question, we know we're sitting here. Where is the center point in relation to where I am? And it's in the same x-plane. In other words, it's not over here. It's not 2 units away from us. It's right in line with where we are. So if it's right in line, it's said to be at I of 0. Because if we're sitting here, the next block we need to execute is the one that will put us to number 3. So in that block, we need to identify not only where we're going to end up, which we've already done, but where is the center of my circle in relation to where I'm sitting right now. Don't worry, we're going to go through this plenty of times. It's kind of complicated, but it's something you have to know, because this is one way the control processes circular commands. The next thing we have to do is say, okay, where is the circle center in Y? So the y-axis runs up and down, right? So I see the circle center is on the minus side, or the downside, of where I'm at by 2 inches. So therefore the j, which is substituted for y, becomes minus 2.0. And the last thing we have to tell it is what direction we want to go in. G02 for clockwise. So over here we'll say G02 is a clockwise arc. G03 is a counterclockwise arc. I'll let that sink in for just a minute, and then I'll show you another way that I tend to think about this. Make it a little easier. Finding that I and j is kind of tricky, as you see. What we're basically saying is that I and j identifies the offset, or the location of the circle center from where we are in x, and where the circle center is from where we are in y. So the way I think about it is, always, a circle begins, and if we picture this point as if it's a temporary datum, just like this, this we know is our coordinate system datum. But if you now visualize this datum point as a temporary location, if that now is our temporary location, what I want to know is, what are the coordinates of the circle center based on the temporary coordinate system? So the temporary coordinate system, putting it right over where we are, the circle center becomes x0, y minus 2, right? But remember, we're now talking about circle center relationships, so instead of saying x and y, you simply say I and j. So I works with the x value, and j works with the y value, and all you need to do is visualize a temporary datum located at the point we're sitting before we cut the circle. So now, block number 3 is executed. We're telling the control, we got to here by saying G01, x minus 8, y 5, that puts us here. Now we want to go there, but we want to tell it, hey, you got to go there in a clockwise motion. These are the coordinates you need to end up. And these are the x and y location pair of where the center of the circle is, based on this being my temporary location. So let's try it down here. What I'll first do is clean up the board a little bit so that you can see it easier. I've marked it all up here, but we now visualize the datum points like this, or the segment points rather. So this is point number 4, this is point number 5, and the drawing tells us that the circle center is 2 units over, and it's 2 units up from the end point. So the circle center is 2 units over, and 2 units up. So the circle center will come into play as we've shown. So we've just done the GO2 that got us to this point. Our machine is now sitting at spot number 3. So now what we want to do, because we want the next move to be a straight line, we need to reinstate G01 right here, because we don't want it to make an arc here in any way. So we have to restate our G01. X minus 6, y minus 4. So now we're sitting right here. We're sitting there. This now becomes our temporary, again, think of this as a temporary datum position. That's a temporary datum position. So now, I'm sitting here, I want to get to point 5. We already know the x and y values from the actual datum. But now we want to determine where is the circle center in relation to our temporary datum mark. So where is it? It would be at x 2.0. And because it's on the same level, it would be at y 0, right? So what do we got to say here? Instead of saying x 2.0, y 0, we say I 2.0, j 0. And what's the last thing we have to say? The last thing we have to say is it clockwise or counterclockwise? Well, this one is counterclockwise. So now, instead of saying GO2, we simply say G03. And now we have a complete circular interpolation block. Then, to end up on point number 6 correctly, we need to restate G01 so that it doesn't try to cut some sort of radius there. And that is the basic of what we call circular interpolation. GO2, GO3, circular interpolation. G01, linear or straight line movements. G00, rapid straight line movements. So that is what we now take a step further. We're talking about circles, circular interpolation. We have a little exercise for you to try at this point. Page number 27 of the manual. Here is our part. Here's our datum. Here are the points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Make yourself a program that correctly uses linear interpolation where appropriate and circular interpolation around these 3 arcs. When you're ready to review it, turn the tape back on and we'll go through this.